Hi everyone. Today, we are diving into the least understood and most mysterious continent on our planet, Antarctica. Forget the sprawling, shapeless white blob you see on a map. Prepare to explore a world where the history of our Earth is frozen deep within 5 kilometers of ice, hiding ancient megacraters, entirely unknown life forms, and staggering resource reserves that could fundamentally redefine the global geopolitical map. Antarctica is easily the most enigmatic of all Earth's continents. In the 21st century, it's a place so poorly understood that most people alive today still don't really have a solid grasp of its true size or shape. In reality, Antarctica is the world's 5th largest continent, exceeding the sizes of Australia and Europe combined. To grasp the true scale, consider this. If you overlay Antarctica on North America, you would find it is significantly larger than the entire contiguous 48 U.S. states. Placed over Europe, it would stretch from the far northern reaches of Norway down to Iran and Iraq in the southeast, extending well past Ireland to the west. It is a genuinely massive place, yet it is almost completely empty of permanent human life. The human population of Antarctica ranges from as many as 4,000 people during the warmer Antarctic summer months to as few as only 1,000 during the long, dark, and savagely cold winters, when the continent is plunged into months of total night and temperatures plummet below -34 degrees Celsius, -30 degrees Fahrenheit. The reason for this extreme isolation is not just the brutal cold, but the unthinkable remoteness. The nearest major settlement, Ushuaia, in southern Argentina, is approximately 1,000 kilometers, 620 miles away. Yet, this relatively short distance is separated by what is perhaps the most dangerous body of water in the world, the infamous Drake Passage. Here, the Southern, Pacific, and Atlantic Oceans merge, allowing winds and oceanic currents to circle the globe unimpeded. This freedom lets them continuously build speed and power, culminating in waves that can reach up to 20 meters, 65 feet, in height during extreme storms. It is little wonder that, due to these conditions, explorers likely did not sight this frozen landmass until 1820, when it was first recorded by a Russian vessel. A truly unique boundary separating the Antarctic from the rest of the world is the Antarctic Convergence, or polar front. This is not a geographical line, but an oceanographic zone where the cold, dense waters of the Antarctic Circumpolar Current, the strongest ocean current in the world, sink beneath the warmer subantarctic waters. This zone, often 30 to 50 kilometers wide, is the biological and climatic boundary that defines the Antarctic ecosystem, preventing warmer currents from reaching the continent and contributing to the incredible abundance of krill. The official record for the lowest temperature ever measured on Earth with a thermometer is -89.2 degrees Celsius, -128.6 degrees Fahrenheit, set at the Soviet Vostok station on the 21st of July 1983. However, in 2013, NASA satellite measurements taken over the ice dome summit of Dome Fuji in East Antarctica recorded an even more chilling temperature, -98 degrees Celsius, -144.4 degrees Fahrenheit. At temperatures this low, the air becomes so dense it can severely damage a person's respiratory system, and metal becomes as brittle as glass. The history of reaching these frigid extremes is as dramatic as the landscape. The early 20th century marked the heroic age of Antarctic exploration, a fierce competition to map the continent and be the first to reach the South Pole. The famous race pitted Robert Falcon Scott of Britain against Roald Amundsen of Norway. Amundsen, with his expert use of dogs and skis and his decision to prioritize speed over science, reached the South Pole on the 14th of December 1911. Scott's team arrived a month later, only to find the Norwegian flag already there. Tragically, Scott and his entire party perished on the return journey, their supplies depleted and their bodies ravaged by the unrelenting cold. The contrasting fate of the two expeditions is a sober lesson in logistics and adaptation to the extreme Antarctic environment. Even more legendary is Ernest Shackleton's Imperial Transantarctic Expedition aboard the Endurance. After their ship was crushed by the Weddell Sea ice in 1915, Shackleton's crew of 28 survived on the drifting ice for months. Their ultimate survival, culminating in Shackleton and 5 companions undertaking an impossible 800-mile open boat journey to South Georgia to find rescue, is still celebrated today. not as a race or a scientific victory, but as the ultimate triumph of human will and leadership. Even 2 centuries later, we still know next to nothing about what is hidden beneath the ice. The Antarctic ice sheet covers more than 98% of the continent's surface. Its average thickness is over 2 kilometers, 1.2 miles. But in the deepest places, the ice can reach almost 5 kilometers, 3.1 miles, thick. To visualize that, you're looking at the height of 6 Burj Khalifas stacked one on top of the other. This crushing weight is why 61% of all the fresh water on the planet is locked within the Antarctic ice. If all that ice melted, the global sea level would rise by approximately 60 meters, 200 feet, leading to catastrophic coastal flooding worldwide. The ice shield is so vast that we genuinely know more about the surface of distant worlds than the actual land surface beneath Antarctica's frozen shell. Less than 10% of the sub-ice continent has been properly mapped by aircraft using radio echo sounding. The ice itself is not just frozen water, it is Earth's most accurate climate archive. By drilling deep into the ice, scientists extract ice cores, long cylindrical samples that trap tiny bubbles of ancient air. Analyzing these bubbles allows us to determine ancient greenhouse gas concentrations and temperatures, revealing our planet's climate history. The longest core, retrieved by the Epica project, reached nearly 3,270 meters, reconstructing the climate for the last 800,000 years. But scientists are now drilling for the million-year ice core in the remote Doomsday Sea region. This core aims to double the length of our climate record, which is critical because around 1-2 million years ago, the dominant glacial cycles on Earth shifted from every 41,000 years to every 100,000 years. This transition is poorly understood, and the million-year core could unlock the secrets of this major climate shift. Furthermore, scientists analyze other potent greenhouse gases, like methane and nitrous oxide from the same air bubbles, confirming that all 3 major heat-trapping gases have current atmospheric concentrations far exceeding any natural fluctuations seen in the last 800 millennia. The small amount of information we do have is startling. Firstly, beneath the ice, Antarctica is not a single landmass. Its true geology is divided between the young, volcanically active West Antarctica and the ancient East Antarctic Craton. The Craton is a stable piece of continental crust, one of the oldest geological features on Earth, with a crustal thickness of up to 50 kilometers, 31 miles. In contrast, West Antarctica's crust is thin and actively rifting, making it seismically and volcanically active. This rift system, similar to the one in East Africa, is thought to be a significant source of geothermal heat that contributes to the melting and instability of some of the huge subglacial lakes and glaciers, regardless of surface temperature changes. What's even more surprising is that Minor Antarctica is part of the Pacific Ring of Fire, a continuous belt of active volcanoes. The highest active volcano on the continent is Mount Erebus. Hot steam released by this volcano has carved vast tunnels in the ice, creating subvolcanic ice caves where the temperature can reach a balmy 25 degrees Celsius, 77 degrees Fahrenheit. In 2017, researchers analyzing soil samples from one such cave found traces of DNA from small animals. Some of the traces could not be linked to any known species, showing close relation only to arthropods like shrimp or spiders. Given that there are at least 15 other active or semi-active volcanoes across Antarctica, entire oases of unknown life could be flourishing beneath the ice. Subsurface mapping has also revealed colossal geographical features. In 2019, the deepest canyon on Earth's land surface was discovered. Hidden beneath the Denman Glacier, this canyon plunges 3.5 kilometers, 11,500 feet below sea level. Another giant feature is the Gamburtsev Mountains, discovered by Soviet researchers in 1958. These mountains are comparable in scale to the Alps, yet are completely buried under a layer of ice more than 600 meters thick. Crucially, Antarctica is not entirely covered in ice. In the region of Victoria Land are the McMurdo Dry Valleys. These are the driest places on Earth, where snow and ice have been absent for millions of years due to katabatic winds and near-zero humidity. Conditions here are considered the closest analog to the surface of Mars. The only liquid water feature is the Onyx River, Antarctica's longest river, which flows only for 2 months during the summer thaw. Here, scientists have found cryptoendoliths, microorganisms that survive by living inside the pores of the sandstone rocks, shielded from the brutal UV radiation and desiccation. In the late 1950 seconds, scientists began detecting a large gravity anomaly in East Antarctica. In 2006, a team from Ohio State University hypothesized that the cause might be an ancient meteorite impact crater, 480 kilometers, 300 miles wide, buried beneath the ice. If confirmed, this would be the largest crater ever discovered on Earth. Its size is almost 3 times that of the Chicxulub crater that killed the dinosaurs, and it is thought to coincide with the Permian-Triassic extinction, about 251.9 million years ago, also known as the Great Dying. It is entirely possible that the deep and mysterious Antarctic ice sheet has been concealing the true cause of the Great Dying all this time. Hidden beneath the surface are approximately 675 liquid subglacial lakes. The largest of these is the infamous Lake Vostok. Discovered by Russian researchers, it lies about 4 kilometers, 5 miles, beneath the ice sheet, and is thought to have been completely isolated from the rest of the world for at least 15 million years. This isolation is what makes it a vault of evolution. In 2012, a Russian team successfully drilled down to the liquid surface. Subsequent analysis of clean samples identified DNA that closely matched a species of codfish. The interest in subglacial lakes like Vostok and Lake Mercer goes far beyond terrestrial geology. For astrobiologists, they are the perfect analog for the potentially habitable oceans hidden beneath the ice shells of Jupiter's and Saturn's moons, such as Europa and Enceladus. In Lake Mercer, which was explored in 2019, scientists found the remains of tardigrades, water bears, and other microorganisms. Studying how life survives here, in complete darkness, under immense pressure, and subsisting entirely on chemosynthesis without photosynthesis, could provide us with direct clues on how to search for and potentially discover life on other icy worlds in our solar system. The marine ecosystem itself presents astonishing biological anomalies. One famous phenomenon is Antarctic gigantism, where many invertebrates, such as sea spiders, giant isopods, and massive sponges, grow to immense sizes. This is primarily attributed to 2 factors: high oxygen concentration in the cold water. Cold water holds more dissolved gas, and an incredibly slow metabolism, which allows organisms to grow throughout their unusually long lifespans without hitting growth limits. Furthermore, the fish of the Southern Ocean, belonging to the suborder Notothenioidae, have evolved a unique adaptation. They produce antifreeze proteins, AFGPs, that circulate in their blood, preventing the formation of lethal ice crystals and allowing them to live in water that is constantly at or below freezing point, sometimes as low as -1.8 degrees Celsius. A few species, known as icefish, have even lost the genes for hemoglobin and red blood cells entirely, relying solely on the vast amount of oxygen dissolved in their cold blood plasma. In West Antarctica lies the single object causing the most alarm in the global scientific community. Today, the Thwaites Glacier, often dubbed the Doomsday Glacier. It is critical because it rests on a seabed that slopes downward toward the continent's center, making it extremely vulnerable to warm ocean water. If it melts completely, it would raise global sea level by 65 centimeters. Crucially, it acts as a giant plug holding back the entire West Antarctic ice sheet, and its collapse could lead to a chain reaction causing a sea level rise of up to 3 meters. Thwaites' critical neighbor is the Pine Island Glacier, PIG. Together, they form the unstable duo of West Antarctica. Both are retreating rapidly, and PIG has lost over 1,500 square kilometers of its ice shelf in recent decades. This retreat is driving the theory of marine ice sheet instability, MESI. MESI proposes that once the glacier's grounding line retreats onto a downward-sloping bed, the process becomes self-sustaining and irreversible until the glacier hits a stabilizing ridge or completely disappears. A newer, more alarming threat to these massive glaciers is the mechanism of hydrofracturing. This occurs when surface meltwater pools in crevasses and fractures. Since liquid water is denser than ice, it expands the cracks as it refreezes, eventually leading to a sudden, catastrophic shattering of the ice shelf from within. This process accelerates the breaking off of massive pieces of ice, known as tabular icebergs. The largest ever recorded iceberg A68, calved from the Larsen Sea ice shelf, and was nearly 6,000 square kilometers in area. Its subsequent breakup in 2020 to 2021 released a phenomenal amount of fresh water, impacting ocean stratification and marine ecosystems. Antarctica is also the foundation of a unique marine food chain, built on krill, small planktonic crustaceans whose total biomass may exceed 500 million tons. Krill is the primary food source for almost every animal in the Southern Ocean, including the baleen whales, which migrate thousands of miles to gorge on it, consuming up to 4 tons per day, as well as seals and penguins. The health of this ecosystem is dependent on the stability of sea ice, which is where krill, eggs, hatch, and juveniles feed. The most vulnerable are the emperor penguins, whose entire breeding cycle relies on stable fast ice, sea ice, anchored to the land. Climate models suggest that, by the end of the century, nearly 90% of emperor penguin colonies will be quasi-extinct due to sea ice loss. In response to these threats, the Ross Sea, a highly productive area off the coast of West Antarctica, was designated in 2016 as the world's largest marine protected area, MPA, covering 1.55 million square kilometers. This groundbreaking agreement, negotiated by 25 nations, restricts fishing to protect the krill and their predators. On a more positive note, the international effort to combat the ozone hole, discovered over Antarctica in 1985, is a major success story. The Montreal Protocol banned ozone-depleting chemicals, and today, the ozone layer is recovering and is projected to fully heal by 2060. In addition to all this science, beneath the Antarctic ice sheet lie massive untapped reserves of natural resources. In 2024, British parliamentarians raised the alarm about the results of a Russian scientific survey in the Weddell Sea, which reported a potential oil field with reserves of 511 billion barrels. To grasp the scale, at the current Brent crude price of around $63.90 USD, 2025 data, the potential value of this single field could be approximately $32.65 trillion USD. This single field could exceed the value of the entire annual nominal GDP of the United States. Beyond oil, Antarctica, as a fragment of the ancient supercontinent Gondwana, is also believed to hold massive reserves of mineral resources, including iron ore, copper, gold, nickel, platinum, and critically important rare earth elements, essential for modern electronics and green technologies. The estimated concentration of these rare earths in East Antarctica is particularly high. This makes the continent highly attractive to major global powers. The disruption of the treaty in 2048 could be spurred not just by oil, but by the desperate need for these strategic elements. The only thing currently preventing the exploitation of these resources is the Antarctic Treaty System, ATS. Signed in 1959, the treaty froze all territorial claims, banned military activity, and dedicated the continent exclusively to science. This system of scientific diplomacy requires claimant states to cooperate with non-claimant states, essentially allowing nations like China, India, Brazil, and South Korea to build permanent research stations and expand their influence, securing a seat at the table for any future negotiations without having to make an official claim now. To gain a voice in the ATS, a nation must become a consultative party by demonstrating substantial scientific research activity, which today includes 29 nations with voting power. This requirement fuels a quiet but intense geopolitical race to build research infrastructure. However, the treaty's crucial element is the Protocol on Environmental Protection, or Madrid Protocol, which is what specifically prohibits mining and resource extraction. The ban on mining can only be lifted by the unanimous agreement of all 29 consultative parties. This prohibition is not set to expire. Rather, the entire protocol becomes eligible for review in just 24 years, in 2048. If even one nation decides to withdraw from the protocol, or if climate change melts enough ice to make extraction economically viable, the system faces collapse. The Russian-discovered oil field is located directly within the most highly contested part of the continent, claimed simultaneously by the United Kingdom, Argentina, and partially Chile. This ties back to the Falkland Islands, fiercely disputed since the 1982 war, as the UK's control over them forms the legal basis for its Antarctic territorial claims, which directly overlap the giant oil field. When 2048 arrives, the world's increasing need for energy, the melting ice, and the potential $32 trillion value will force global players to actively contest the status quo. Antarctica will cease to be merely a continent of science. It will become the final, and perhaps most expensive geopolitical flashpoint on the planet. Thank you for watching. We'd love to hear your thoughts. Tell us in the comments what surprised you the most in this video, or what you found the most fascinating. If you enjoyed this video, be sure to leave a like and subscribe to the channel. Many more thrilling, shocking, and mind-blowing stories are coming soon.